So for this one, okay, this one's a little bit different. You know, we want to have $500,000, right, for retirement in 20 years. We know the account we're using, whatever it is, it's earning 10% interest. So now this is a little bit different because we have to figure out what our deposit is, what our monthly deposit is, okay? And again, this is different, right? But we're still making many deposits. So this is, in fact, so we're in the same situation as the previous example because we're making many deposits. What's different, though, is we know what A is, as we'll see. So we're making monthly deposits, right? So this is the same formula as before. And here's our notation. What's different, though, is we have A here. A is $500,000. PMT is what we're looking for, right? They say, how much do we need to deposit each month? Right? So that's unknown. The R, 10%. So we convert it to a decimal, so we get 0.10 or 0.1. Remember, with compounding, right, unless stated otherwise, we're always assuming it's compounded as often as we make deposits. It's compounded as often as we make deposits. We're making monthly deposits, so it's compounded monthly. So in a year, it's compounded 12 times, so N is 12. T is how long this is going on for, you know, the number of years we're making deposits, and this is 20 years. Now that we have that, okay, we have our formula, and that's this. Okay. So we have to figure out what this is. And again, it's really just like what we did in the previous example. You know, what I would do is work with the innermost parentheses first, and then work your way outward. You know, order of operations, in other words. And that's what I'm doing. So it turns out 0.10 over 12 is about 0.008333. It keeps on going, but I'm just using 6 decimal places. You know, in the end, we're going to round to 2, but the more decimal places you use, the more accurate your answer is. So we have this. 1 plus 0.10 over 12, which is this, as you can see. And that's being raised to the 12 times 20. I know I did skip a step here, but what you would have is 1.008333 raised to 240, which gives you this value. So that's what we get here. We have 1.008333, and that would be raised to the 240, 12 times 20. So that's what this number is. And we subtract 1, okay? Like so. And we end up with this. But remember, PMT is what we don't know. That's what we have to figure out. Right? So we have this here. Okay. Now, how do we get PMT? Well, what I did was I carried out this quotient, right? That's what this number is. And then we divided. Carry out the quotient, then we divided. Okay. So we're solving for our unknown, in other words. Okay, so what is PMT? PMT is equal to this quotient, and that turns out to be about this. But again, we want to round to 2 decimal places. And if you do, you'll get 0.44. So you'll get 658.44. So our monthly deposit is about $658.44. Monthly payment. Excuse me, monthly deposit, or that's what that is. Not payment. Okay, let me fix that. And remember, part B, we want to, it's the same as the previous example. We want to know what's the total amount that we put in. In other words, how much are we putting in from deposits? All the deposits collected together, right? Each month we're putting in $658.44. Well, over the course of 20 years, how much are we going to end up depositing? Well, we just multiply. So we have this times 12, right? Because this is per month. So in a year, we have 12 months per year, and then this is going on for 20 years. And you end up getting this amount, which is $158,025.60. I know it's tempting to skip the 12, multiplying by 12. You know, you might accidentally forget it, but don't. You know, because this is per month. And this is 20 years. So multiplying by 12 gets you into the right units. So we're putting in a total amount of this, $158,025. That's how much we're putting in altogether. But remember, since the money's in the account, there's interest being accumulated as well. And we know the balance is going to be $500,000. And if we're putting in this amount, what's left over is going to come from interest. The amount left over is our interest. How do you get that? You just subtract. Right? This is the balance. This part comes from us. So whatever else is there must be interest, which we subtract. This is our interest. This is how much we're making in interest. So that's what we get there. Okay, that's good. All right. Okay, so any questions on that? I mean, this one I was going to have you guys try. We only have about like 13 minutes left, so I think it might be better if we do it together. But so this one is, so we'll do this one together. So let me just get to this. But it's very similar to the one we just did actually. We want to have $800,000 in retirement in 30 years from now, let's say. And we know the account is earning 6% interest. That's our annual interest, okay? 6%. So we want to know first, how much do we need to deposit into the account every month? Okay, so again, we have many deposits here. We're making a deposit each month. And because we're making a deposit each month, we're going to assume the account is compounded each month. That's what we're assuming. That's what we're assuming. Okay, so it's just like before. We have to figure out then what our monthly payment, what our monthly deposit is. So again, we're going to use the same formula because we're making many deposits. Not only that, okay, not only that, but we have our values of the variables here. You know, the balance, which is what we want after T years, is $800,000. We don't know what the monthly deposit is, right? That's what we're looking for. That's our PMT. We know the interest rate is 0.06. We have to write it as a decimal. Again, we're assuming it's being compounded monthly. So monthly meaning it's compounded 12 times a year. And this is in 30 years, so this is going on for 30 years. Because of that, we have our formula here.